Hello students, let us continue this session on areas related to circles. In the previous session, we had discussed exercise 12.1. Now let's begin with exercise 12.2. The general instruction is unless stated otherwise, use pi is equal to 22 upon 7. The first question is to find the area of a sector of a circle with radius 6 centimeter if the angle of the sector is 60 degree. Here we have a circle with center O. The angle inclined at the center by an arc ACB is 60 degree. Now that we need to find the area of the sector, here area of sector OACB we will find. This will be equal to the angle upon 360 degree multiplied with pi r square. Here the angle inclined is 60 degree upon 360 multiplied with 22 by 7, and they have mentioned that 6 centimeter is the radius. We can further simplify 60 and 160 on simplification, it becomes 1 upon 6. 22 by 7 multiplied with the 6 with 6. One of the 6 get cancelled. We'll be getting 6 multiplied to 22, which is 132 upon 7 centimeter square. If you want, you can further simplify. I'm presenting the answer as it is. Second question. Find the area of a quadrant of a circle whose circumference is 22 centimeter. First, what is the meaning of quadrant? Quadrant refers to 1/4 of the circle. Quadrant of a circle is 1/4 of a circle. Hence, 1/4 of 360 degree is 90 degree. So the 90 degree angle is formed. Here, the angle inclined is 90 degree. Angle subtended by the arc, minor arc at the center is 90 degree. For instance, let me consider the radius. Let the radius of the circle be r. They have mentioned the circumference. They have given the circumference as 22 centimeter. Therefore, I can use the formula 2 pi r equal to 22 centimeter. We can find the radius. R will be equal to 22 upon 2 pi, which is 22 upon 2 times 22 into 7. So we get the radius as 7 upon 2 centimeter. I'll mention that quadrant of a circle subtends an angle of 90 degree at the center. Therefore, area of quadrant will be equal to 90 degree upon 360 degree multiplied to pi r square. So 90 degree upon 360 degree multiplied to 22 by 7 into 7 by 2 into 7 by 2, because the radius is 7 by 2. One of the 7 get cancelled. 94 times is 360. 11 times. So we'll be getting 77 upon 8 centimeter square. Question number 3. The length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. For convenience, I'll consider a clock wherein the mention of 5 minutes is there. In 5 minutes, there will be 30 degrees. The reason is one complete hour will make 360 degree, which has got 60 minutes. So 360 upon 60 into 5 will be giving 30 degrees. So the angle inclined is 30 degree. With respect to 30 degree, we can find the area. So let me mention that we know that the minute hand makes an angle of 360 degree in 1 hour. Therefore, angle formed in 5 minutes will be 360 upon 60 degree multiplied with 5 will be getting 30 degrees. Therefore, area swept by the minute hand in 5 minutes will be equal to the angle formed is 30 degree upon 360 degree multiplied to pi r square. So 30 upon 360 will be 1 upon 12 multiplied to pi times 14 square. On further simplification, I'll take 22 upon 7 multiplied to 14 into 14. 7 2 times, 2 6 times, 2 3 times, 2 11 times. We'll be getting 154 upon 3 centimeter square. Question number 4. A chord of a circle of radius 10 centimeter subtends an angle 90 degree at the center. Find the area of the corresponding minor segment and major sector. They have mentioned that use pi value as 3.14. The chord AB subtends an angle 90 degree at the center. So area of this particular sector minus the area of triangle, we will be getting area of minor segment. So first what we need to do is we'll find out area of the sector OACB. Area of sector OACB will be equal to, this is for the first part, 90 upon 360 degree multiplied to 3.14. They have specified that you have to use 3.14 multiplied with 10 into 10. So this is 4 times. (94 times is 360). 2 times, 5 times, once again 5 times. We'll be getting 25 multiplied to 3.14. On further simplification, it is 78.5 centimeter square. Now that I'll find area of triangle OAB. The area of the triangle OAB is half into base into height. Here it's a right angle triangle, so OA, if we consider as base, OB will become the height. So it is half multiplied to 10 into 10, we'll be getting 50 centimeter square. Therefore, area of minor segment will be equal to area of minor sector minus area of triangle. Here the area of minor sector is 78.5 centimeter square. Area of triangle is 50 centimeter square. Hence we get 28.5 centimeter square. This is the area of segment. Now the question is to find area of the major sector. So area of major sector we can find by considering the angle 270 degree. That can be done, or else what we can do is area of the circle minus area of the minor sector. Therefore, the second one, I'll take area of major sector. I'll use the formula 270 degree upon 360 multiplied to pi r square. Pi r square is pi multiplied to 10 square. We can simplify this as 3 upon 4. The reason is it is divisible by 9. 9 3 times, 9 4 times. So 3 upon 4, 0, 0 getting answer into 3.14 into 10 into 10. So this can be simplified 25 times. So 75 multiplied to 3.14. We get it as 235.5 centimeter square. These are the areas of minor segment and the major sector. Question number 5. In a circle of radius 21 centimeter, an arc subtends an angle 60 degree at the center. Find the length of the arc, area of the sector formed by the arc, area of the segment formed by the corresponding chord. Here I have considered the chord to be AB. ACB is the arc which is subtending angle 60 degree. O is the center of the circle. 21 centimeter is the radius. So we need to find out first one as length of arc. So length of arc will be equal to theta upon 360 degree multiplied to 2 pi r. Now the angle theta is 60 degree. So 60 upon 360 multiplied to 2 pi r. 2 into pi into radius is 21. So we get 1 upon 6 multiplied to 2 multiplied to 22 by 7 multiplied to 21. 3 times 3, 7 times 7, 7 getting cancelled, we'll be getting just 22 centimeter. This is the length of the arc. Second one we need to find is the area of sector OACB. It will be 60 upon 360 multiplied to pi r square, which is 22 by 7 into 21 into 21. So you get 1 upon 6 multiplied to 22 by 7 into 21 into 21. We know that 3 times is 6. 3 7 times is 21. 1 of the 21 get cancelled. So we get 11 times 21, which is 231 centimeter square. Now third one we need to find is the area of a segment. Area of segment ACBA will be area of sector minus area of triangle. Here area of sector we have found as 231 centimeter square minus area of triangle we need to find, and this particular triangle is a equilateral triangle. The reason is, if you consider perpendicular OD, the angle formed here is 90 degree. So 90 degree, 30 degree, this will be 60. Same way this will be 60. We get equilateral triangle. Area of equilateral triangle is 3 by 4 into side square. Here the side is 21. So 21 into 21. And for the simplification, I'll just mention this as 231 minus 441 root 3 upon 4 centimeter square. Since they have not mentioned here, I have now taken the root 3 value as 1.73 and then simplified. I've just written the answer in a complex form. I have not simplified further. Question number 6. A chord of a circle of radius 15 centimeters obtains an angle 60 degree at the center. Find the area of corresponding minor and major segments of the circle. Here both the segments are asked. So first let me find out area of the minor segment. Area of minor segment will be area of minor sector minus area of triangle. For that, I will first find out area of sector OPQ, OPRQ. So area of the sector OPRQ will be 60 upon 360 multiplied with 3.14 multiplied with 15 into 15, because the radius is 15. So this will be 1 upon 6. On further simplification, we get it as 117.75 centimeter square. So the area of minor segment will be equal to area of sector OPRQ minus area of triangle OPQ. Again, as we have discussed in the previous question, when the angle formed here is 60 degree and these are the isosceles triangles, sorry, these are the sides of isosceles triangle, these two angles are equal. When we find the angles, we get 60 degree each, hence it is equilateral. So 117.75 minus root 3 upon 4 into side square is 15 into 15. So this has to be simplified. So we get 117.25 minus 56.25 into 1.73. .73 multiplied to 56.25 is 97.3125. So we get 20.4375 centimeter square. This is the area of minor segment. So we can find out area of major segment. It will be area of circle minus the area of minor segment. Area of the circle is pi r square, so it is 3.14 into 15 into 15 minus, we have found the area of minor segment. So we need to subtract. When we simplify this, it is a 225 multiplied to 3.14. We get 706.5 minus 20.4375. We get 686.0 625 centimeters square. Hence we have found the corresponding minor and major segments. Question number 7. A chord of circle of radius 12 centimeters subtends an angle of 120 degree at the center. Find the area of the corresponding segment of the circle. Here the angle subtended is 120 degree. Here I have considered a perpendicular. I have named it as OV. So the angle formed here is 60 plus 60, 120 degree. Here we need to find area of the corresponding segment of the circle. Here the area of the sector OSUT minus area of the triangle OST will give us area of segment, minor segment. The problem here is we can't directly find the area of the triangle. The reason is in the previous questions the angle formed or angle subtended was 120 degree, but in this question we have got the angle which is subtended by the arc SUT is 120 degree, so it becomes a little difficult to find area of the triangle. For that we'll make use of the application of trigonometry. If you observe in triangle OVS, if you consider cos of 60 degree, this will be OV upon OS. Cos 60 degree is 1 upon 2, which is equal to OV upon OS is 12. So we get OV as 6 centimeter. Now I will consider sine of 60 degree. Sine of 60 degree will be SV upon OS. Sine 60 is root 3 by 2, which is equal to ESV upon 12. So we get the length of OV, the length of SV as 6 root 3 centimeter. ST will be the sum of SV plus VT. Since SV and VT they are equal, I can take 2 times of SV. We get 2 times of 6 root 3. So 2 times of 6 root 3 is 12 root 3 centimeter. I'll find out area of triangle OST. It is half into base will be ST multiplied to the height OV. We have found the height OV. So half multiplied to the base is 12 root 3 multiplied to 6. We get it as 36 multiplied to 1.73. Because root 3 value is 1.73. On multiplying we get 62.28 centimeter square. Now I'll find out area of sector OSUT. This will be 120 degree upon 360 multiplied to pi r square. Pi value 3.14 into r square is 12 into 12. 12 3 times is 360. So 1 by 3 into 3.14 into 12 into 12, we get 150.72 centimeter square. Therefore, area of sector minus area of triangle will be equal to area of segment. So area of segment is 150.72 minus 62.28. We get it as 88.44 centimeter square. Question number 8. A horse is tied to a peg at one corner of a square-shaped grass field of side 15 meter by means of a 5 meter long rope as shown in the figure 12.11. Find the area of that part of the field in which the horse can graze. So I can make a sector with the help of this rope. The length of the rope will become the radius. That's common sense. In increase in grazing area, if the rope were 10 meter long instead of 5 meter, so the new radius will become 10 instead of 5. So we need to find the sector. So in both the cases, we'll be finding the sector. For convenience, I'll consider this point to be O and this part to be AB. So if I want to find area of the field where the horse is grazing, I need angle. Here, since it is a square, the angle formed is 90 degree. So first I'll find out area of field where horse can graze. Will be equal to area of sector. I'll name the sector as OABO. Here it is 90 degree formed upon 360 into pi r square. Pi value is 3.14, r square is 5 into 5. So we get 19.625 meter square area. The second, if the radius is increased now, instead of 5 meter, it is 10 meter. So area of sector will be here the new area will be 90 upon 360 multiplied to 3.14. Now instead of 5 we'll take 10. This becomes 78.5 meter square. Therefore, increase in grazing area will be equal to 78.5 minus 19.625. The difference is going to be 58.875 meter square. There are totally 14 questions of this chapter. 6 more questions we shall take up in the next session. That's all for today's session. Thank you.